of the lesson. Okay, so let's say I will choose a very simple function, x squared plus 1. Everyone knows how to graph this function. I'm going to choose an interval, of course. We have to look at an interval. Very simple interval, 0, 2. So I have a function. I'm going to graph it in a moment. I have an interval, 0, 2. And I'm asked now to find the area under f of x on 0, 2. Okay. 1, 2. When x is 0, 0 plus 1, 1. When x is 1, 1 plus 1, 2. And when x is 2, 2 squared, 4 plus 1, 5. So I'm going to say 5 here. So here's the graph. This is the graph of f of x. And here is the area in question. So I have a function. I have a closed interval between 0 and 2. And I'm asked to find this area under the graph of f of x on the interval 0, 2. In this class, there are other methods in the next class. But in this class, we're going to look at the method called leftmost point, the method called rightmost point, and the method called midpoint. And you can say, what's all this? What are you doing with this? Okay, in a moment, we'll get there. So in addition to these 3 methods, or I will not be able to determine the area using these 3 methods without giving or without deciding upon n number of subintervals. Number of subintervals. And you can say, subintervals, what are you talking about? Okay. So let's choose n equals 2 first. 2 subintervals. Yes, we can use subintervals with different width, but they will always be equal. Equal width. Okay, with n equals 2. So the graph, I don't want to go back there. I'll graph it again. Zero, 1, and 2. So the width of subinterval, the width of another subinterval, it's called delta x, of course. Delta x, width of each subinterval. What is it? B minus A divided by n. What is B? What is A? Well, of course, we're talking about the interval. A comma B, in our case, the interval is 0, 2. In our case, n equals 2. So, 2 minus 0 is 2. Divided by 2, in our case, delta x is 1. So let's illustrate with the leftmost point. Leftmost leftmost point. What does that mean? Leftmost point. We are going.
Can you stop for a second?
Yes.
Where did you get the n equals 2? Were you given that, or is that?
Yes. So we're building it slowly but surely. We are going to look at 2, then at 4, then at 8.
But you were given n equals 2.
Yes, n has to be given to us. Yes.
Okay.
So they want us to find. We cannot find the exact area. We only have to approximate at this point. So n equals 2. 2 subintervals. We determined, once we know that we have 2 and we have the length of the interval between 0 and 2, we put in 2 minus 0 divided by 2, and that's how I got the 1. The leftmost point means I will create a rectangle with the base times the height at the leftmost point of the interval. The height is where the function is. And then I go across. So I found one rectangle. I need one more because I have 2. Base times height, where the function is, and go to the right. And this is the other rectangle. So the area with left 2 is base times height, 1 times f of 0, plus base times height, 1 times f of 1. 1 stays outside, I don't need it anymore. F of 0, remember the function we picked was x squared plus 1. F of 0 is 1, plus f of 1 is 2. So the area, it's an approximation, it's a gross estimate, of course, is 3. Is this an underestimate or an overestimate of the correct exact area?
Underestimate.
Of course, under. Because these pieces are missing. Awesome. Now we're going to illustrate with 2, but the rightmost point. Still 0, 1, and 2. Here's what happens next. Base times height with the rightmost point. Base times height, go across with a rectangle. Base times height, go across with a rectangle. So the area in this case with right 2 is base times height, 1 times f of 1 plus 1 times f of 2. F of 1 I already know is 2, and this is times 1, and f of 2 is 4 plus 1 is 5. So the answer is 7. Is this an underestimate or an overestimate of the correct area, of the exact area?
Over.
Over. Because of these areas. So can I say that the exact area is somewhere between 3 and 7? For sure.
Yeah.
Perfect. We have to illustrate with the third one, which is the midpoint. Still n equals 2. So the delta x is still 1. Now careful here. Let's illustrate how we determine an approximation using the midpoint. Midpoint, base, midpoint here is 0.5, and midpoint here, of course, is 1.5. Base, midpoint, up, where the function, where the vertical hits the function, across. Midpoint, up, hits the function, across. So then the area now, the area with midpoint 2 is still base times height, 1 times f of 0.5 plus base times height, 1 f of 1.5. So what do we have is f, so the function was again x squared plus 1. So 0.5 squared is 0.25 plus 1, 1.25 plus 1.5 squared is 2.25 plus 1, 3.25. So 4.5. Of course, this is the best estimate. So again, see the difference. It's an increasing function. Because it's an increasing function, the leftmost point will be an underestimate. Because it's an increasing function, the rightmost point will be an overestimate. And this is the best estimate. Okay, stay with me.
So question,
Yes.
since we know that the midpoint is the best estimate, do we have to do the left and the right, or do we just go right to midpoint?
Exercises will ask you to calculate with both.
Oh, okay.
But I promise in the numerical ones, I will not ask you for more than 4. Max. Max. Okay. So we calculate with n equals 2. Let's see how it looks. We're not going to calculate it, but let's see how it looks with n equals 4. Zero, 1, 2, 0.5, 1.5. So now delta x with n equals 4. Delta x will still be 2 minus 0, but divided by 4. So this is 1/2. Base will be 1/2, let's say with the right, times the height, plus base for the area of the next rectangle, times height, plus base times height, plus base times height. So this will be the first, the rightmost rectangle, then the next rectangle, and then the next rectangle, and then the next rectangle. 0.5 times f of 0.5 plus 0.5 times f of 1 plus 0.5 times f of 1.5 plus 0.5 times f of 2. So remember what we just did. Delta x times f of x1 plus delta x times f of x2 plus delta x times f of x3, where x3 is 1.5, plus delta x times f of 2. Well, that's the connection to this. Nobody wants to write this. What if they're 10, 16, 64? No. From I equals 1 to the 4th rectangle, from the area of base times height. So this expresses 0.5 times f of 0.5 plus 0.5 times f of 1 plus 0.5 times f of, and so on and so forth. That's why, and that's where we need the summation notation. What is this? The sum of areas, base times height, plus base times height, depending on where we are, I equals 1 through 4. This bears the name of the mathematician who invented it, Riemann sum. So this is the Riemann sum, because we don't want to write it like this. We want to write it condensed, and we have to use the summation notation if we do that. Now, question. Will the area, the estimate of the area with 2 subintervals be better or worse than the estimate using 4 subintervals? Which one is better, with 2 or with 4?
4.
Of course. Excellent. Stay with me, stay with me, stay with me. 16. We did n equals 2. We did not, but we illustrated with 4. I want to continue with 8. Then I want to continue with 16. And then with 64. I jumped over 32, and so on and so forth. Where am I going?
To infinity.
Excellent. When we talk about n approaches infinity, what do we have in mind? Which operator?
The limit.
We have the limit operator when n approaches infinity. From the Riemann sum. So, exact area equals the limit as n approaches infinity. The number of subintervals fills in everything in the area, infinity, from the Riemann sum. The sum from I equals 1 through n from delta x f of xi. This is the exact area. No approximations whatsoever. Nothing. All these are approximations. This one is the exact. The limit of the Riemann sum. And again, where does this come from? Is the product of the areas of each rectangle. Base times height plus base times height plus base times height plus base times height. 4. But we want infinite. N approaches infinity. That's what this is. And that's why we need the summation notation. That's why we started with this tonight. So I can use it here. So we had to establish what it meant first and how to calculate it, so that when I put it in the Riemann sum, you understand what I'm trying to do. Okay. I know we only have 15 minutes left, but I'd like to show one example.